Okay, good day to everybody. We're done with chapter 3. Let's proceed to chapter 4. Chapter 4 is resultants of force systems. Okay. At the end of the chapter, the students, or you, the students, no, should be able to define a moment of a force, find the moment of a force by applying the principle of moments, use the cross product to find the moment of a force about a point or about a line, know the properties of a couple, find the resultant of force systems in 2 and 3 dimensions, and lastly, determine the resultant of distributed loads. Okay. So first topic for this chapter is moment of a force about a point. I think you already have a background on how to deal with this topic. I think you have discussed it before in high school, I think, high school or in your physics class. Okay, so moment, sometimes it's called torque, but there are differences between moment tapos although meron namang sometimes these two terms are used, interchangeably. Okay, so moment of a force, it is the tendency of a force to rotate about the body on which it acts about a given point or axis. Moment arm or lever arm is the perpendicular distance from the point or axis to the line of action of the force. Or moment center is the point where the body rotates or tends to rotate. So, how do we compute for the moment of a force? So, ang kailangan natin sa pag-compute ng moment, of course, is yung force that causes the rotation, or twisting or rotation, the force. And we need the lever arm or the moment arm. What's the moment arm? That's the perpendicular distance between yung point and the force. Okay, so for example, we have a point here, point O, and we have a force F. So this would be the perpendicular distance D. So the moment of force F relative to point O or about point O is equal to the product of the force and the perpendicular distance between the force and the point or axis, hindi, D. So ganun lang kasimple. So force times distance, that's the moment of the force about a certain axis or about certain point. Okay. Ayan. And we discussed this theorem, Varino's theorem, or principle of moments. So the principle of moments states that the moment of a force about a point is equal to the sum of the moments of its components about the same point. So we have an illustration here, but let's try to have another illustration. For example, we have a point here, and you're about to compute for the moment of this particular force. Okay. F natin, ayan. And this is D, ayan. Alright, so the moment of this force, yung Varino's theorem or principle of moment states that the moment of this force about point O, this is point O, is also equal to the moment of its component. So if you want to compute for the moment of the force of this force, no? Yung moment daw ng force na ito relative to point O is also equal to the moment of the components about point O. So that's Varino's theorem. Okay? So ganun lang kasimple. Okay? So that's the principle of moments. So ganun lang kasimple yun. I-multiply lang natin yung force and then the perpendicular distance between the force and the point or axis where we are summating or taking moments. Okay? So let's have examples of this application of this topic. Alright, let's solve this problem. Determine the moment of the force F. F here is in its vector form or Cartesian vector form about point O. Okay, so how do you solve this one? We're going to apply the principle of moments or the Varinian's theorem. Ano yung Varinian's theorem again? The moment of this force is also equal to the moments of its components relative to point O in this case. No? So we have Fy, the component of this force about the y-axis or along the y-axis. This is the component of the force relative to about the x-axis or Fx. Yan. And from the given value or magnitude of force, it's in Cartesian vector form. So Fx here is positive 40. Yun eh. So it's 40 newtons, and y or j here is 80 newtons siya. Okay? Oh, nagkakaroon ng ayan. Yan yung video natin. Alright, so that's it. So those are the components, and we are to summate moments about O. So anong kailangan natin para makapag-compute tayo ng moment? The force and then the perpendicular distance. Okay. Okay. So nasan na? So compute na natin. So the moment about O, let's say m sub O na lang, is equal to yung moment ng Fx about O plus yung moment ng Fy about O. Again, I forgot to discuss kanina, ang sign convention natin, okay, kasi there are merong dalawang direction ng moment sa 2 dimensions. So pwede siyang clockwise or counterclockwise yung moment natin. So ang sign convention natin sa pag-compute ng moments, kapag clockwise, okay? So pag clockwise yung direction, positive yung moment natin. Kapag counterclockwise yung direction, negative yung moment. Okay? So the positive and negative there signifies the direction of the moment. So pag positive, ibig sabihin clockwise siya. Kapag negative naman, that means counterclockwise. Although in many books, no, sa mechanics, iba yung sign convention nila, baliktad, no. Counterclockwise yung positive, clockwise yung negative. Just to be consistent, I think this has been your sign convention since physics, maybe perhaps pati nung high school, if you had this particular topic in high school, that clockwise moments are positive. Okay, and counterclockwise is negative. Just to be consistent, but if it's more convenient for you to use a different sign convention, if you want counterclockwise to be positive and clockwise to be negative, that's fine with me. Okay, just be consistent with the application, So hindi pwede na yung first step ng solution clockwise positive, tapos yung second step naman naging clockwise negative, na baka malito kayo dun sa application ng sign convention. So just be consistent na lang sa application ng sign convention. But sa discussion natin, I will use clockwise positive na sign convention. So negative yung clockwise na moment. Okay? So yung moment ng Fx, so let's say Fx times, let's say dx na lang. So yung dx natin dyan ay yung perpendicular distance between yung Fx sa point O plus yung Fy natin times, let's say, dy na lang. Okay? I hope that is clear. Alright. So, we know fx and fy. What we need to identify muna ay yung dx and dy natin. So, what is dx, what is dy? So, fx, perpendicular distance ng fx sa point O. We have this law called law of transmissibility. So, pwede niyang extend yung yung line of action ng fx. And then, yung distance natin, extend natin yung line of action ng fx. So, yung perpendicular distance natin, okay, yung moment arm ng fx relative to point O, yan yung perpendicular distance. Okay? Perpendicular distance. Extend nyo lang yung line of action ng force natin. Okay? So, fx, it tends to rotate, no, about point O. Kapag in-apply mo yung fx, okay, ito yung moment arm natin. So, moment arm natin is 150 millimeters. Okay. So, iikutin niya clockwise yung ikot. Okay. So, fx would tend to rotate, no, clockwise relative to point O. So, pag clockwise, again, positive. Next naman, yung rotation ng Fy natin. Ano yung perpendicular distance? Again, you can extend yung line of action ng Fy. Ito yung point O natin. Mag-drawing lang tayo ng horizontal line. Okay. So, ito yung perpendicular distance, that is 360 millimeters. And Fy tends to rotate, no? Rotate counterclockwise. So, pag in-apply natin yung Fy, counterclockwise yung rotation, pag ganon. Okay? Rotation niya. So, ganon. Pag ganon, ikutin niya counterclockwise. So, negative yung moment ng Fy relative to point O. Okay? So, the moment at O then is equal to Fx is 40, so clockwise yan, so positive. 40 newtons times perpendicular distance. Naka-millimeter siya, convert na lang natin sa meters, but if you prefer na naka-millimeter pa rin, okay lang naman. Yun ang problema yun. So, 40 times 0.15 meters ito Fy tends to rotate counterclockwise, so minus 80 newtons times its moment arm. Okay, that is 360 mm, or it's 0.36 meters. So the moment of F relative to point O is equal to ilan? Negative. Hello. Alright, so the answer is negative 22.8 Newton meters. Ayan, so that's the moment of the force about point O. Okay? So, yeah. Next problem. Okay, determine the moment of the 650-pound force about point O and B. Points O and B. Okay, so this is point O, point B. Alright. So, since we're going to apply the principle of moments again. So, i-resolve na lang natin. Kasi although you can solve naman yung talagang perpendicular distance between the force about point O, the axis where point O lies, where point B lies, no? But it would be ano, it would be much easier for us to solve for the moment of the force if we just resolve it into its components. No? Okay, so component ng force about the y-axis, fy I should say. This is fx, fy. Okay. I-resolve na lang muna natin yung mga components niya along x and y axis. So fx is 573.916. Is this in pounds? Yeah. Pounds. Fy is 305.157 pounds na. So, saan galing yung mga values na yan? Kanina na. So, automatic na yan. Alam na natin, trigonometry. So, Fx is equal to 650. X component natin. Directed to the right. So that is adjacent side, so 650 cosine of 28 degrees. So that is this, no? 573.916 pounds. And Fy is equal to 650. So opposite side siya, so sine 28 degrees. So that is 305.157 pounds. All right, so that's where these quantities are computed. No, that's how we have arrived to these quantities fx and fy. Alright, so let's now solve for the moment of the force about O muna tayo. So about point O, okay. So moment at point O is equal to yung moment ng fx and then moment of fy. Okay, so this is point O. Kailangan nating malaman yung perpendicular distance, o yung moment arm natin, perpendicular distance between fx and point O, the axis where point O lies. So sa pag mag-extend ulit tayo yung ating fx, ano, line of action ng fx. So ano yung perpendicular distance natin? So kapag fx, yung perpendicular distance niya ay ito. Okay, ito yung point O natin. So mag-drawing lang tayo ng horizontal line sa point O. Okay, horizontal line sa point O. Okay, and then vertical line from the line of action ng point A natin. Sa point A, drawing lang tayo ng vertical line. Okay, yan. And then yung perpendicular distance niya, ito na yon. Yan yung moment arm niya. That would fx would now tend to rotate, okay, in the counterclockwise direction. Okay. So fx is counterclockwise. Fy naman, yung fy natin is counterclockwise din. Pag ganun siya. Okay? Counterclockwise din. Moment arm ng fy natin, this distance. So yung fy, mag-extend lang ulit tayo ng vertical distance. From point O, mag-extend ulit tayo ng vertical distance. And then mag-drawing tayo ng horizontal distance. So pwede rin yan, pwede yan. So parallel yan, ano? Parallel. So mag-drawing ka lang ng horizontal distance perpendicular to both lines. Ayan. Perpendicular to both lines. Ito lang horizontal distance. Yun na yung moment arm natin. Which is, ito, 4 inches plus 6 inches. Yung kanina, moment arm ng fx natin, ito, no, that's 4 inches. So, fx, so counterclockwise siya, so negative 573.916 pounds times yung moment arm ng fx natin ito. So, pag fx, drawing tayo horizontal. Sa point O, drawing ulit tayo ng horizontal. And then, mag-drawing tayo ng vertical line, perpendicular line, no? Vertical, perpendicular line between the two line of actions, two lines. Okay? So, ito yung perpendicular na distance natin. Okay? So, yung distance niya, parehas lang siya dito, parehas lang siya dyan. So, which is 4 inches. 4 inches. Okay. And then, moment ng Fy about point O. So, that's also counterclockwise. So, minus Fy, that is 305.157 pounds. Times yung moment arm niya. So, mag-drawing ka lang ng vertical lines. And then you draw a horizontal line perpendicular to both lines or lines of action. Okay, so ang perpendicular distance natin dyan ay ito. Yan din yun. Yan din yan, which is 4 plus 6. So that is 10 inches. Okay, so the moment at O is equal to, yung moment at O is equal to 5347.234 pound inch. So negative yan. Negative means counterclockwise yung direction ng moment. Okay, or you may also write the answer na 5347.234 pound inch counterclockwise. So you may remove yung negative sign there, but you have to indicate yung direction ng moment. Okay? So that's it. Next, we need to solve also the moment of this force about point B. So MB is equal to, again, yung moment nito, Fx about B. Fx about B. So, ang sinabi ko kanina, mag-drawing tayo ng, kung nahirapan kayo mag-identify ng moment arm. Okay. So, at point B, we draw a horizontal line. So, ang siguro diskarte natin. Okay. At sa point A, since yung line of action ng Fx natin is horizontal, of course. Okay. And you draw a line, vertical line, perpendicular to both lines. Okay? So, iyan na yung moment arm. So, perpendicular. Ayan. Yan na yung moment arm ng Fx about B. So, anong distance yan? That's 10 plus 4. And Fx would now tend to rotate. If you try to imagine yung rotation, ito yung line of action ng Fx, ito yung point B. Okay? So, mag-rotate yan. Pag ganun, i-rotate niya. So, i-rotate. Kung yan yung point B, ito yung perpendicular line natin. Parang papaikutin niya yung line na yan counterclockwise. So, counterclockwise. So, that is negative 573.916 pounds times yung moment arm, which is 10 plus 4, that's 14 inches. Okay, that's the moment of Fx about B. Plus, yung moment of Fy about B. So, since, sige, anong kwan natin? Ang diskarte naman para ma-solve natin yung moment arm nito. So mag-drawing tayo ng vertical line sa line of action ng FY. Vertical line din dun sa line of action ng line of action sa may point B. So vertical. And then we draw a horizontal line perpendicular to both lines. Okay? So ito yung horizontal line, yung perpendicular. Yan din yung distance dyan. Kahit dyan ka mag-drawing ng perpendicular line, pares din. Alright, so ito na yung moment arm ng FY about B. Okay, yung horizontal line na perpendicular to both lines. And that is actually 6 inches. Okay? So, since FY tends to rotate, counterclockwise yung rotation. Yan yung point B, ito yung FY, so magro-rotate yon clockwise, counterclockwise I should say. So negative FY is 305.157 pounds times yung moment arm niya na 6 inches. Okay. So, and the moment of the force about B is equal to negative 9865.766 pound inch. Okay, na yun. Negative means counterclockwise yung direction ng moment. Or you may also write yung answer natin na 9865.766 pound inch. You may remove the negative sign, but you have to indicate yung direction ng moment counterclockwise siya. Okay? Alright, so that's how we solve for the moment of the force about points O and B.